Hey folks, Mr. Ray here with our next lesson in quadratics. So we're going to continue our journey into quadratic equations and graphs. Um, the last lesson we learned about some of the key characteristics of a graph of a quadratics equation. It actually formed a shape called a parabola, which can either open up or down. We'll be looking at that in a second. And a parabola had a very interesting point called the vertex, which was either at the very top where the curve went from going down to going up, or vice versa. It could be at the top when it changes direction from going up to going down. And a parabola also had a y-intercept all the time, and it had anywhere from 0 to 2 x-intercepts. Okay, so now that we know some of the characteristics of the graph and what the equation looks like, we're going to start with the most basic of the quadratic graphs, and that would be the equation y equals x squared. That's where all other quadratic equations come from, and we're going to apply some transformations to that graph. So I'm just going to introduce those names. Okay, so just a reminder, we'll start using the term zeros for x-intercepts as well. We're going to interchange those. Basically it means the same thing. You could think of x-intercept is where the graph crosses the x-axis. You could also look at it from the perspective the x-intercepts are where the y values are 0. So it's really the same thing. But you'll start hearing the term zeros more often now. Okay, so transformations are what we apply to what we call the base graph, y equals x squared, and we have three types of transformations. We have translations, reflections, and stretches. And I guess I should add in compressions. That's part of stretches as well. So a translation, and we're going to see these in a few seconds, just be patient, is when we take the shape, the parabola shape, and we just move it left, right, or up, down, or a combination of the two directions. Okay, so we call them vertical translations if it goes up or down, and horizontal translations if it goes left, right. You can have none of them, one of them, or both of them. Okay, just basically moving the shape around. Okay, we also have reflections. So this is where, in the case of a parabola, we change it from opening upwards to opening downwards. We basically flip the y values from being positive to being negative. Okay, and the last one is a stretch or compression. And this is basically where you take the output and you could almost think of it as physically stretching the parabola, like grabbing onto the arrows and pulling up. It's going to make it narrower, or you could compress it, like pushing it down, and that's going to make the parabola wider. Okay, and we're going to see how that works. We'll skip this for a second. I'm going to go over to the iPad here and show you what I'm talking about. Okay, so we've got our Desmos graph here. You can see right now what's showing up in the graph is the graph of y equals x squared. You can see, remember that point 0, 0 was the vertex. In this case, that point happens to be all three of the key points. It's the vertex, it's the x-intercept, and it's the y-intercept. So it's kind of a jack of all trades point with the base function here. Over here, if you see this equation here, y equals, and I've got some parameters in here, a, h, and k. Those are the transformation parameters. We're going to talk about, explain what they do. Right now, the value of a is set to 1. Okay, the value of h and k are set to 0. So if you plug those in, this is really just y equals x squared. Okay, so that's nothing, no transformations applied. Now, if I if we use the slider here to experiment with A, so if I change A from 1 to go higher, you can see that the parabola is getting narrower. And then when I go back down, back through 1, and when I'm between 0 and 1, positive 1, you can see it's getting wider very quickly. And then at 0, something strange happens. It goes completely flat. Okay, and that's because basically if A was 0, this whole thing was 0. So basically what you're getting here is a line y equals 0, which is not it's not a quadratic relation, it's not a parabola. That's why when we define the equation, we always say that for it to be quadratic, A cannot be 0. Okay, so what happens when it goes negative? Well, go back down to 0, and if I start going negative, you can see it's reflected. It's now opening down, and the more and more negative I get, the narrower it gets. And between -1 and 0, you can see it's compressed. So it's wider than y equals x squared, but it's not quite flat. So if I go back to say y equals 1, okay, so the A value from what we just saw, if A is negative, you could see it reflected. So basically all the points on the graph, for example, this point here at 2, that's the point 2, 4 there, it actually went down to -4. So the y values just flipped to the negative version, so the negative sign. Okay, so when A is negative, it does this reflection. When A is greater than 1, it starts getting compressed. It starts getting narrower, and also when it's less than -1, it gets narrower down here because it's reflected and compressed. Sorry, and stretched. Okay, and when it's between greater than 0 but less than 1, that's when it becomes more bowl-shaped. So we see that's compressed, and when A is between -1 and 0, it's reflected and compressed down here. Okay, so the A value is pretty powerful. Notice that when we change A, we're changing the shape, and we could possibly be changing the direction that it's opening if it's negative. Okay, so that's the one that has a lot of power. Okay, the H value, you can see it here in the equation. It's actually changing the X value before it gets squared. So we call this changing the input into the function. So if I make, right now this is y equals x squared. If I make H positive, you can see that it's basically sliding along to the right. So we call that translating to the right. And if H is negative, so right now it's back to 0. If H is negative, it translates the whole parabola to the left. So you can see the shape is not changing, it's only the position on the graph. So it's almost like I took a transparency of that graph and I just moved it to another spot horizontally. Okay, and if I move that back to 0, okay, so H is responsible for horizontal translation. So if H is bigger than 0, then that translates that many units to the right. If H is negative, it moves that many units to the left. Okay, and then K, if I make, right now K is 0. If I make K positive, you can see that it's actually moving the whole parabola upwards that many units. Okay, so for example, right now K is 5. It's moved every point on the graph has shifted up 5 units. You can see it's affected the vertex. It's gone from 0, 0 to 0, 5. And then when I make K negative, it shifts it down that many units. So right there, shifted down 10 units. You can see the vertex is at 0, -10. Okay, and I can apply all 3 of these at the same time. For example, maybe I want, so let's think about the vertex. Let's move the vertex to say 2, 4, or let's go 2, 5. So say we want the vertex to be up right about there. So that means I'm going to make H2 because I want to move it to the left 2, and I want to move it up to 4. So vertical translation up 4 from here, and horizontal translation to the right 2. So shift to the translate 2 units to the right and 4 units up. That's what H and K are doing. And then if I wanted to, make the parabola wider, I make it somewhere between 0 and 1, like that. If I want to make it narrower, I move it to whatever value I want that's over 1. And if I want to make it open down, I have to make a negative. So from these 3 parameters, you can basically create any of the infinite number of possible parabolas that there ever could be. Okay. Now the other important point about this, and I was just kind of talking about that, is the H and the K values actually it moves every point that many units to the left or right, and that many to up or down, and that includes the vertex. Now remember, the vertex always started at 0, 0. So whatever the value of H and K are, that's where the vertex will be. Okay, so like I said, we want the vertex to be at 2, 4. So H was 2, K was 4. If I change K to be -5 and H to be, let's go to 6. So right now H is 6, K is -5. So you can see that there's X equals 6 and K equals -5. The vertex is at 6, -5. Okay, so that's how we can basically use these 3 parameters to transform the graph of y equals x squared into any parabola we want. So let's go back to the lesson now, and we can kind of summarize what we just kind of discovered there. Turn the light back on. Okay, so this part down here, or actually we could go yeah, let's go to do this first. Make it a bit wider. Okay, so to graph y equals x squared plus k, so this is looking at the k value. We're going to translate vertically k units, so up or down depending on the sign of k. If k is 0, it doesn't change it vertically at all. It just stays where y equals x squared was. Okay, and then when we're looking at h, remember the h is inside the brackets with the x, and the whole thing is being squared. So this is the value of h is responsible for moving the graph, translating the graph left and right. If h is greater than 0, it moves to the right. If h is less than 0, it moves to the left. And then we've got the a value. So this is where it stretches or compresses and also reflects. So this is a little bit hard to understand, but hopefully you remember the description on the iPad. So if a is negative, it's reflected. And remember, a can never be 0, because if it is, then it's not a parabola anymore. And if a is greater than 1 or less than -1, it's stretched. And if a is somewhere between -1 and 1, except for 0, then the graph is compressed by that number, by that factor. Okay, notice that the terminology, it's very important. So for the a value, it's a multiplier, so we always talk about by a factor of. Okay, so because we're multiplying by that factor. When we're talking about translating, we say translate horizontally or vertically, or we could just say translate left, right, up, or down so many units. Okay, so it's very important that you don't mix these up. You don't say it's translated by a factor of, and you don't say it's stretched by so many units. That would be wrong, because these units here, they're adding or subtracting, whereas this factor is multiplying. Okay. Now remember, I talked about how the h and the k basically give you the vertex. So we've kind of created a brand new, not kind of, we have created a brand new equation, a quadratic equation, but it's a slightly different form than we were used to. Remember, the original equation that we started with looked like this. No brackets at all. We had an x squared term, an x term possibly, and a constant. So that was definitely a quadratic equation. We call this standard form, and we'll be referring to it on future lessons. This is a new form. It's basically, it will have an equivalent standard form, but when we write it in this form, it's very powerful because it gives us the vertex directly. If we can just find those two numbers, hk, we know what the vertex is, and because it gives us the vertex so simply, we gave the name vertex form. Okay, so if you want the vertex form gives it to you just by looking, whereas if I had something in this form, standard form, I don't have a clue. Even if I had numbers here, there's nothing that pops out and says what the vertex is. Okay, and we will, in a couple lessons from now, we'll be talking about how we can change an equation that looks like this in standard form into an equation that's in vertex form. Okay, all right. So let's try a few things out here. So I've got some exercises. Hopefully, I've got quite a few here. So, hopefully by the time we get halfway through, you'll be asking me to hurry up. Okay, so what we're going to do here is describe the transformations that we would need to make, starting with the base graph, y equals x squared, and turning it into each of these individually. Okay, they're all separate questions. They're not kind of building on each other. Okay, now the first thing I'm going to do, and you'll see how useful this will be, is for each question, each of these equations, which is in vertex form, I'm going to write the values of a, h, and k, and then from those parameters, I'm going to describe the transformations. You'll see how easy it can be if you do it that way. Okay, so let's remember what that equation looked like. It's y equals a bracket x minus h squared plus k. Okay, so right beside the equation, I'm going to write the values. So in this equation, now the a is easy to find because it's always the number to the left of the x. There might be a bracket there. There doesn't have to be though. So in this case, a is equal to 5. H is equal to, so if you're looking for the h, it's going to be in brackets with the x. So if you don't see any brackets here with x plus or minus something before it gets squared, h is just 0. Okay, and then k, similarly, k will be the number after this to the right of the squared. Okay, it'll be something squared plus or minus a number, and in this case there's nothing to the right, so also k is equal to 0. Okay, now what we're going to do now is describe the transformations directly from here. So I could basically, I don't even have to look at this equation now. I could just look at these and finish the question. Okay, so a equals 5. We always start with the a value when we list our transformations. That's the order they happen. So h and k, the order doesn't matter between the two of them, but the a transformations always have to go first because of bed mass. Remember we said a is like a multiplier, so multiplication is always higher importance than adding and subtracting. Okay, so if I look at the a, so remember if a is greater than 1, that means it's a stretch. So I'm just going to put the number 1 because there could be several transformations. I'm going to say stretched by a factor, and then we just put the number 5. Okay, and we look to see if it's negative. It's not, so it's not reflected. And then the fact that h and k are both 0 means nothing's going on there. so we're not translating it anywhere. So that's all that's happening here. Y equals 5x squared means we've started with the graph y equals x squared and we stretched it by a factor of 5. Okay, so let's try the next one here. Actually, we'll go down this way. So again, a this time is 0.5. H and k are both 0. Okay, so what's going on here? Well, you have to remember 0.5 is between 0 and 1. So that means it's actually compressed. It's made wider. So compressed by a factor of 0.5. And it's not negative. Okay, so no reflection, nothing going on with H and K, so we're also done that one. So this one, if we started with y equals x squared, we would, if we compressed it by a factor of 0.5, we would get this equation or this graph from the equation. Okay, let's keep going with this. So this time we got a equals -2, and again H and K are both 0. So we're just really working on the a at first. So this time you notice a is negative, so I like to always get the negative out of the way. So the fact that it's negative means it's been, you could say reflected, I like to say vertically reflected. Vertically reflected, and you don't have to give any numbers there. It's either reflected or it's not. You never say reflected by a factor. That's part of the stretch or compression. Okay, so we've handled the negative sign. What does the 2 mean? So again, since it's greater than 1, that means it's stretched. And we say by a factor of. Okay, now here's one of the most common mistakes. We've already handled the fact that a is negative by saying it's reflected, so we don't need to use the negative part in our factor. So you don't say stretched by a factor of -2, you just say stretched by a factor of 2. Okay, so let's keep going. This time a is equal to -1/2. H and K are both 0. Okay, so hopefully you're getting the hang of this. So again, I'm going to look for a first. So it's negative, so I'm going to say vertically reflected. Okay, and then the fact that it's a half, we can strip off the negative sign like the last time. The fact that it's a half means that's compressed by a factor of 1/2. Okay, and that takes care of the a. We handled the negative, we handled the 1/2. H and K, nothing going on. Okay, now we're going to get into the other parameters, because this time, if you look for a, I don't have anything to the left of the x. So what's the value of a? Well, you might think it's 0, but it's not. If that was 0, that would mean this whole thing is 0. Because it's a multiplier, the default is 1. So if it's not stretched, compressed, or reflected, a is 1. Okay, and then this time we got h. So h is what's inside. So this is where you have to be careful. So if you remember the template we're using, it's x minus h. So what's the value of h? Well, if you said 2, you're correct. Okay, you don't just take that number -2 because it's x minus h. So what does h have to be for it to be x minus 2? H would have to be 2. So you kind of have to do a little flip of sign here, but then you never have to worry about it again. So h is 2, and for k, there's nothing to the right of the squared, so that's 0. So for h and k, remember the default values for nothing happening, no transformations. Default values are 0. For a, the default is 1, because remember, a can never be 0. Okay, so all we have to take care of is the h equals 2. So remember, that's the horizontal, the left-right translation, and since h is positive 2, that means it's translated And this time we use the terms 2 units, and then I'm just going to say the direction. So it's to the right, 2 units right. Okay, let's try another one here. So this is a lot like the last one. So a is equal to 1 because there's nothing in front, so the default is 1. This time h is going to be equal to, so remember, you got to think about that sign there. It's x minus h. So what's h have to be? H would have to be -5. Okay, and then nothing to the right of the squared, so k is 0. Okay, so what do we do here? Well, that's default, nothing going on there, so it's just the horizontal translation. So translated 5 units, and because it's negative this time, it means it's to the left. Okay, and that's all that's happening. So this graph here, we take the graph of y equals x squared and we just shift the whole thing 5 units to the left. Okay, let's start looking at the last parameter, the k we haven't really seen going on. And like I said, the k is easy to find because it's the number that's being added or subtracted after the squaring happens. So in this case, a is equal to 1, h is 0 because there's nothing inside the brackets with x, but k this time is 1. Okay, so k being 1, that's the vertical, that's up or down. So we always start off with the verb translated, and it's 1 unit, and since k is positive, it's up, so 1 unit up. Okay, keep going with this one. A equals 1, h is 0, nothing inside brackets, k is -3, so this time translated 3 units, and because k is negative this time, the direction is down. So with k, the direction's either up or down. Down if it's negative, up if it's positive, just like with h. If h is positive, you go to the right. If h is negative, you go to the left. Okay, now we're going to start seeing more than one being used at the same time. So this is more typical. So this time still a is 1. This time h. So think about the sign, x minus h. So h has to be -2. And k is -3. So this time you can see 2 numbers there. You can always know h is inside the brackets with the x, and k will be to the right of the squaring. It's once you know where to look, you shouldn't be getting mixed up. Okay, so this time nothing going on with a, so it's just translations. Now what I like to do, if I have 2 different translations going on, h and k both are being used, I put that into one single sentence. It's really 2 translations, but I'm combining the sentence. Sorry, translated. So if I look at the h first, that's 2 units left and 3 units down. If you want to separate them into 2 sentences, that's totally fine. I'd like to try to combine it so I don't have to write the word translated twice, but it's up to you. So this one here, J, we've got A is 1 still. We've got H, hopefully you're getting the idea with the H. It's not -7, it's +7. And K is +8. So again, we do this in one statement. Translated. So 7 means 7 units right. And 8 units up, because it's +8. Okay, you notice I'm using the same words over and over, and I'm not using words like moved or flipped or made skinnier. Okay, it's important that we use the right math terminology. Okay, so if you get in the habit, don't take shortcuts. Look for the right word. Try to remember them. Okay, now the last two, we're using all three parameters. So we've got a equals 2, we've got h equals -4, and we've got k equals -3. So we always talk about the a first. So it's not negative, so it's not reflected. It's greater than 1, so that means it's stretched by a factor of 2. Okay, and then the h and k I'll put into one sentence or point here. So h is -4, so translated, and it's negative, so it's 4 units left. And 3 units down because it's -3. And again, you don't put the negatives with the number. I didn't put translated -4 units left. These are always going to be positive when you describe the transformation. These are always positive, and the stretch or compression is always positive. So you'll never actually write any negative numbers here. What you'll do is kind of incorporate the negative sign into the direction, left, right, up, down, and whether it's stretched or compressed or reflected. Okay, this one's got everything in it. So this time we've got a equals -1/4 because it's to the left of the x. The h is -1, x minus h, so h has to be -1, and k is 12. Okay, so I always like to look for we always start with a. I look to see if it's negative. This time it is. So I just say vertically reflected. Okay, and then we'll look at the numerical part, the 1/4. We can forget about the negative part. That's already been talked about here. So the 1/4, that's between 0 and 1. So that means it's going to be compressed by a factor of 1/4. Didn't put the negative right, you don't do that. And then finally the h and k, that's our translation statement. So translated, this time 1 unit left and 12 units positive, so it's up. Okay, so hopefully you've got a good idea of how to do this now, and you can see how important it is to strip off the a, h, and k, because I never had to look back at the equation to figure out how to write the transformations here. I could take these directly and write this without seeing the equation. Okay, one other point here. I've seen this happen quite a bit. I could put a fraction here, so like say I put 5/4 here. Now it looks like a fraction, so you might be tempted to say it's compressed, but 5/4 is an improper fraction. It's actually like 1 1/4, so it's greater than 1. So be careful not to fall in the trap of seeing a fraction there and automatically thinking it's compressed. You might have to look at, is that fraction greater than 1, or is it between 0 and 1? Okay. All right, so the next part is nice and easy. So what we're doing is we got the exact same equations from example 1 we just did, and what I'm asking here is two things. What's the new vertex? So what's the vertex of each of these equations? And is it a maximum or a minimum? So maximum, the parabola would look like this. It opened down. Okay, so I could say opens down. And a minimum is when it opens up. So these are always related, right? The direction of the opening tells you whether it's a min or a max. But also, going back to the equation, we know if it opens up or down. Normally, like this is what y equals x squared would look like, and that's when the a value is positive, it opens up. So when it opens up when a is greater than 0, and it opens down when a is less than 0, when it's negative. Okay, so this should be pretty quick, because remember the vertex was just hk. Now I've got h and k and a written on the previous page, but let's just, you could refer to that, no problem. But let's try to do, so the new vertex here, so we think of the values of h and k are both 0. So the vertex is 0, 0, and we look at the a value is positive, so that means it opens up, which means it's a minimum. So minimum. Okay, so that's all we're doing. So we are looking at h and k, that gives us the coordinates here. But we also look at the a value. If a is positive, it's a minimum, and if a is negative, it's a maximum. Okay, so let's keep going. Here h and k are still both 0. So vertex is 0, 0, and a is positive, so that's still a minimum. So that's got the same vertex, opening the same way. This time h and k still zeros, but now a is negative, so it opens down like that, so now it's a maximum. You can see how those three things, the value, the sign of a, the opening, and whether it's a max or min, they're all related to each other. Okay, and here still 0, 0 for hk. A is negative, so that's also a maximum. Now we start getting some h and k values. So remember the h value will be 2, and the k value is 0 because there's nothing to the right. A is positive 1, even though it's not there. So if a is positive, that means it opens up, and we have a minimum. Okay, here, this time h is negative 5, k is 0, and again a is positive, so it's a minimum. Now, if I was doing this question from scratch, I'd probably write out a, h, and k, but since we just did that on the last question, you can refer to that, or you can just try to get it directly from the equation if you'd like. Okay, so this time over here we've got x squared plus 1, so h is 0, k is 1, that's the vertex, the point 0, 1. A is positive, so that's a minimum. Okay, here we've got h is 0, k is negative 3, a is positive, so that's a minimum. Okay, now we get some more. This time h is negative 2, k is negative 3, that's the vertex, and a is positive, so still a minimum. Okay, here we've got h is 7, and k is 8, a is positive, so lots of minimums. And here h is negative 4, k is negative 3, a is positive, so it's a minimum. Okay, last one. We've got h is negative 1, k is 12, and this time a is negative, so that means it's a maximum. So again, just like the last question, all of these answers you can get directly from a, h, and k. So I think that's an extremely important technique, is to extract those values, and then it becomes quite a straightforward, repetitive process. Okay, the last example here. This time, remember the first question, we were giving the transformations that were required so we were given the equation and we created the transformations necessary to create this from y equals x squared. Now we're going to go the opposite way. So now we're given the transformations, and we're going to create the equation. So these are the transformations from y equals x squared, and we're going to create the equation. So again, just like all the other questions, we're going to create the values of a, h, and k, and then create our equation from, you guessed it, y equals a bracket x minus h squared plus k. Okay, so this should be pretty straightforward. It's probably easier going this way than creating the transformation from scratch. So stretch by a factor of 2. So what does that mean? That means that a is equal to 2. And there's no reflection listed here, so it's definitely 2. Translated 5 units left. Well, that's horizontal, so that's h. H is equal to, because it's left, it's -5. And there's nothing mentioned about translating up or down, so that means it's nothing going on with k, so it's 0. And now from that we can create our equation. So just plug in our a value of 2. It's going to be x minus -5, so careful. X minus -5 is x plus 5 squared, and because there's no k, we just leave it like that. Okay, next one here, reflected vertically. Okay, so that doesn't give us a number, but it tells us that a is going to be negative. So what I would do is look to see if there's stretch or compression, and there's not. So if it's reflected but not stretched or compressed, it's -1. Okay, remember the default for a was 1. So if all you're doing is reflecting, a turns to -1. Translated 3 units up, so that means that's the k value. So k equals 3 because it's up, +3. And there's nothing mentioned about left or right, so h is 0. Now our equation, so we've got y equals, now you can put -1 or just negative. I'm gonna just put negative. I'll put both of them, but I'll just start with negative. Now the fact that h is 0, when I plug that in, I get bracket x minus 0, which is just x. So I don't really need to keep the brackets. I can just put the x squared like that. Okay, putting x plus or minus 0 is not changing x, it's still x. Okay, and then the k value gets tacked on to the right of the squaring, so +3, negative x squared plus 3. Okay, compressed by a factor of 0.5 for the next one. So that's the a value is 0.5, and there's nothing about a reflection, so that's the final value. Translated 4 units right, so that means h equals 4, and translated 9 units down means k is -9. So when we build our equation from that, we've got a value is 0.5, then we've got x minus 4 all squared, and then subtract 9. All right, and last one, reflected vertically. Okay, so remember that makes it negative for sure, but I'm going to look for the stretch or compression, and there's a stretch factor of 1.5, so it's -1.5. So I've covered both of these with that one number. Translated 2 units up, well, that's our k value. K is +2 because it's up, and 1 unit left means h is -1. And then finally we do our equation, put the value of a, -1.5. So again, x minus -1 turns into x plus 1 squared, and then +2. Okay, so you can see the power of this new equation in vertex form. It's basically created from doing transformations to the graph y equals x squared, but you can see why that form has the name vertex form, because the h and the k in the equation is the vertex. So it's a very powerful equation to have. Okay, got some homework questions here. hopefully you can practice some of the stuff we were doing in the lesson. And in our next couple of lessons, we're going to be looking at the vertex form that we've just kind of created this lesson. We're going to be looking at two things. One, how to graph from the vertex form. It's actually quite nice. And the second is, what if we were given the equation in standard form and we wanted to find the vertex? What would we do? So there's a nice technique for doing that. So that'll be the next two lessons. So until then, make sure you practice this. You're not going to learn this unless you practice it yourself. Okay, so make sure that you attempt the homework because it's required for the next couple of lessons to understand what we're doing. Okay, so until next lesson, have a great day.